My name is Drew Adan. I'm an archivist at the University of Alabama in Huntsville, or UAH. And this summer, Cecilia and I were working on an RCEU project. RCEU stands for Research and Creative Experiences for Undergraduates, where an undergraduate pairs with a faculty mentor and gets a stipend to work on an independent research project for the summer. I was inspired by the recent call for proposals to be a host recipient of the Artemis moon trees, and I thought this would make a great RCEU project to look into the roots, if you pardon the tree pun, of the Apollo era moon trees. So we're going to start, Cecilia's going to start things off, kind of give you some background biographical information on Stuart Roosa, the astronaut in Apollo 14 that brought up the moon tree seeds, and kind of present the Apollo era moon trees in the context of the 1970s. So this actually dovetails really well with the previous presentation. And then I'll take over, talk about the Artemis reboot, and kind of compare those two projects. So.
Hello. So I guess I'll just start. So in 1971, Stuart Roosa, who is the command module pilot for Apollo 14, carried many special mementos in his personal preference kit. And one of these mementos was a tin carrying about 500 tree seeds, and was part of an experiment between Roosa and the U.S. Forestry Service. And this was the moon trees, and it's very understudied. And its history is pretty clouded, which is kind of why we wanted to investigate it. But I think first, by beginning with Stuart Roosa, we can analyze the moon tree experiment's intended purpose. So Stuart Roosa was a rookie class smoke jumper in 1953. And this is his smoke jumping class, and he's pictured fourth from the left. And smoke jumpers jumped out of airplanes into forest fires, and Roosa believed because of the intense training and bravery related to smoke jumping, it would improve his chances of acceptance into the U.S. Air Force cadets. And Roosa's presumption proved correct, and he was accepted into the cadets in 1953 and earned his wings and lieutenant ranking in 1955, soon to begin his career as a fighter pilot. So 9 years after receiving his wings and now a captain, Roosa was offered a place in Class 64 Charlie at Edwards Air Force Base as a test pilot. And this was an incredibly high honor, as only the best were asked, and he served under the famed Colonel Chuck Yeager. And according to Stuart Roosa's son, Christopher Roosa, in his biography, Son of Apollo, his father was always looking for the most impressive opportunity to improve his career. And after Edwards, Roosa would become a NASA astronaut. So 2 years after, he became one of the original 19 chosen for the Apollo program. And he was also the first rookie astronaut. Most served on backup crews before they served on their own mission, but instead Alan Shepard personally picked Roosa to be part of his crew. Before the Apollo 14 flight, the head of the Forestry Service at the time, Ed Cliff, approached Roosa about a potential forestry experiment because of Roosa's smoke jumping past. Roosa served as the perfect representation of the U.S. Forestry Service and their experiment, and this was the moon trees. And during flight, there were no complications with the seeds, but afterwards, the bags burst open and broke due to a decontamination procedure. And at first, they believed it would disrupt the seed growth and the viability of the seeds, but they were able to recover and sort the seeds. And this is a picture of Roosa on the far right holding his tin of tree seeds. So the Moon Tree Project began as incredibly personal to Roosa. He had a very deep connection with nature, and that's kind of why he was involved in the smoke jumpers. And NASA was not originally involved with the moon trees. They did become involved at some point, but the exact date is unknown. What we do know is that the moon tree experiment was not listed under an official NASA experiment in Apollo 14's preliminary science report. And we also know that NASA held the seeds after Apollo 14's flight for a short period of time. Eventually, the seeds were transferred from NASA to the U.S. Forestry Service under the care of Stan Krugman, a Forestry Service official overseeing the project. And so while the project began as personal, it became a generational and even global project, emphasizing its collaborativeness. And to understand how that project became generational, we should inspect the context of the Apollo program and NASA's difficulty with public support and funding during the 1970s. So in his book, NACA to NASA to Now, Dr. Roger Lanius, former head NASA historian, explains how the decline in NASA's overall public support and funding from the US government began before the 1970s and even before Apollo 11. Some attribute the decline in NASA funding to Nixon and his, quote, emphasis on frugality, but the decrease was multifaceted. Historian Joan Hoff explains in her essay, The Presidency, Congress, and the Deceleration of the U.S. Space Program in the 1970s, that the decrease in NASA funding was unavoidable and would have likely happened if Nixon wasn't strict on budget. Nixon wanted to shift the space program out of the space race. And his goal of détente with the Soviet Union led to a project we heard about in the last talk, the Apollo-Soyuz Test Project, or the ASTP. And so by comparing the Moon Tree project, we can sort of better analyze NASA and the country's goals. Both the ASTP and the Moon Trees exemplified cooperation and displayed NASA's achievements. So the Apollo-Soyuz succeeded in Nixon's aim towards a better relationship with the Soviet Union temporarily. The ASTP allowed for the first international mission in space, preparing for future collaborative missions and projects like the International Space Station. To compare, a collaborative effort relating to the Moon Trees is the Moon Tree Foundation, founded by Stuart Roosa's daughter, Rosemary Roosa. The foundation plants second-generation moon trees around the world, forming closer international relationships. In his article, Curating the Space Race, Celebrating Cooperation, Thomas Ellis comments that historians have depicted the 1970s as a decade marked by growing awareness of global interconnectedness, something the ASTP and the Moon Trees represent. Notably, a few original moon trees were planted internationally in Japan, Brazil, and Switzerland. So while the ASTP flight was successful in improving relationships, the ASTP museum exhibits, however, did not result in positive relationships with the Soviets. Ellis later explains in his article that the ASTP exhibits in museums actually led to disruptive collaboration, and that the American museums found the opportunity to express their technological prowess by creating more elaborate exhibits next to their Soviet counterparts. This also seemed to function as a way for NASA to reclaim their importance within American history after the Apollo program. While the Moon Trees never entered direct competition with the Soviet Union, the Moon Trees did aim, it seems, to reclaim NASA's importance within the public. The Moon Trees being planted during the US bicentennial highlighted NASA's ability to be a long-lasting organization and significance within American history. The Moon Trees' hopefully long lives would relate to NASA's hopefully long existence as well. And this is a picture of the first bicentennial moon tree planting. There were multiple moon tree plantings before this, but there was not an official ceremony until Philadelphia. It being planted in Philadelphia also sort of highlights the patriotism associated with the moon trees. One key difference, though, between the ASTP exhibits and the moon trees is that the ASTP exhibits were space tourism sites, and most of the Apollo-Soyuz capsule models could only be viewed at select places in the world. The moon trees, however, were more of local attractions, and diverse seed species were chosen to ensure that trees could be planted across the country, so as many Americans as possible could see them. Another instance that supports the claim of moon trees as local attractions is the Huntsville Times article, Moon Tree Planting at Rocket Center. This article details the Huntsville, Alabama moon tree plantings in 1976, but this article was only available in the Metro report of the Huntsville Times, meaning folks in the surrounding areas and not in the city center were not notified of their local planting. However, most of the moon trees were quickly forgotten after the bicentennial until their rediscovery in the late 1990s. A NASA archivist, Dave Williams, received an inquiry from Joan Goebel, an elementary school teacher from Indiana, asking about a moon tree one of her students found. So Dave Williams, the archivist, was very interested in the project and began research. And he had two primary research methods, and so we sort of took this approach when researching. And he primarily read newspaper articles about the moon tree plantings, and his second method was outreach to the general public. When reading the newspaper articles, Williams ran into an issue. He was not able to track down the amount of moon trees that was claimed to be planted around the country. Many moon trees had no articles detailing their planting, causing him to rely on the public. Williams's method of outreach mimics his research origin story. Without inquiry from the public, and particularly Joan Goebel and her class, Williams may not have ever begun the research, and the moon trees may have been forgotten forever. The rediscovery of the moon trees is often associated with Williams, and while no doubt his contribution to the recording of the moon trees is paramount to the project's survival, the actual discovery was accomplished by an elementary school student. And this sign is honoring the rediscovered moon tree in the 1990s. The student's discovery aligns with the overall student interest in the moon trees. Students seem to be the demographic most interested, both K through 12 and students of higher ed. Whether the moon trees were directly targeted towards students is not confirmed, but specific statistics about the amount of trees planted at schools might offer some insight. So approximately 15% of moon trees were planted at places of higher education, and this is not including elementary schools, because there are some instances of that. This is only including colleges and community colleges. So I truly believe that this is an example of how the moon trees were probably targeted students. And the Moon Tree Foundation that sprung out of the original moon trees, their motto is planting the seeds of inspiration. Additionally, the Moon Tree Foundation provides educational materials for students as part of their donations, further emphasizing the moon trees and their educational impact and connection with students. So in Mary Musgrave's article, Seeds in Space, she outlines NASA biology projects, specifically projects about seeds. And she describes the impact these projects had on students in education. Musgrave highlights the moon trees' inspirational value. However, the moon trees were originally an experiment to test the effects of space on tree seeds. After describing the impact of the moon trees on education, Musgrave follows it with another NASA experiment, SEEDS, or Space Exposed Experiment, developed for students. Musgrave's sequencing of the two experiments implies the moon tree experiment pioneered the way for student education involving seed biology and outreach to the community. Some examples of university involvement with the moon trees is at the University of Georgia, students found their local moon tree because of a group project. Students and educators at university take pride in their local moon tree, including the University of Arizona, where STEM researcher Jim Scotty describes the UA's moon tree's impact on campus. He comments, "It allows the possibility to be inspired a little bit by its journey." These two instances represent the inspirational and educational value of the moon trees. But what do the moon trees inspire for these students exactly? In general, interest in NASA and the space sector, but often these inspirational aspects seem to be delivered within a STEM context, targeting only STEM students. But there's a surprising amount of humanities-related projects inspired by the moon trees. The moon trees have been a muse of multiple creative writing pieces and children's books, including Siobhan Plaza's children's chapter book, Meet Me at the Moon Tree, and Carolyn Crew's poem, Moon Tree Experiment, Apollo 14, 1971. And to finish this off, Basil Tucker's article, Solutions Looking for Problems, How Humanities, Arts, and Social Sciences Can Inform the Space Sector, Tucker outlines the importance of STEM and the humanities collaborating to improve the space sector. Rather than competition, STEM and the humanities should accommodate each other in order to improve the space sector, because each sect offers diverse points of view. This provides us with yet another example of how the Moon Trees emphasizes collaboration. One STEM initiative that furthers the Moon Tree project is the Artemis Moon Trees, which Mr. Drew Adan will talk about next.
Thanks, Cecilia. All right, so I'll be talking about the Artemis reboot. So starting in 2020, NASA launched a social media campaign with the hashtag NASA MoonKit. So this coincided with the planning and testing for the Artemis missions, and it was a public relations initiative that encouraged members of the public to consider what they might carry in their PPK, their personal preference kit, on a hypothetical trip to the moon. The literature promoting this initiative included a history of the PPK from the Gemini era through the present-day International Space Station, and mentioned some of the most famous items that astronauts have included in their PPK, such as the Wright Flyer propeller that Neil Armstrong carried on Apollo 11, and of course Stuart Roosa's moon tree seeds on Apollo 14. People were even encouraged to submit ideas in quote expert mode, which took into consideration the 5x8x2 dimensions of actual NASA PPK bags. But these items that astronauts have included in their PPK are sources of enduring fascination from the public. They're, quote, bestowed with a magical sheen the second they're returned to Earth and essentially become space souvenirs. However, the seeds carried by Roosa and his PPK on Apollo 14, these differ from other such space souvenirs in that they're living things with the inherent ability to propagate their legacy. So thus, the moon trees and their offspring continue to kind of capture the public interest for generations. So inspired by this initiative and the 50th anniversary of the Apollo 14th mission, NASA announced in 2022 that the Artemis 1 mission would include a special payload and that, quote, a new generation of moon tree seeds are bound for lunar orbit. The Resurrected Moon Tree Project is a collaboration between NASA's Office of STEM Engagement and the USDA Forest Service. And the goal is to, quote, create Artemis 1 programming, link it to earth science with conservation education, data literacy, and citizen science with educators and youth nationwide. So one of the first citizen science projects to launch along with Artemis 1 was the NASA Moon Tree Quest. So this activity ran from June to September of 2023, and it sought to re-engage the public with the known surviving Apollo-era moon trees. This was a collaborative effort between NASA Next Gen STEM, the Artemis Education Program team, and the USDA Forest Service. So the Moon Tree Quest urged participants to collect two different types of data using NASA's Globe Observer app. So using the built-in measuring functionality of the app, citizen scientists were first encouraged to find and measure the height of control examples of the species that Stuart Roosa carried in his PPK. These were sycamores, loblolly pines, coast redwoods, sweet gums, and Douglas fir. And then second, the participants would seek out publicly accessible surviving Apollo 14 moon trees using the geolocation features of that same Globe Observer app and take height measurements. The app tracks all currently documented moon trees on public land and alerts the user when they are close to one. This data was harvested from the NASA Moon Tree Archive that Cecilia mentioned. This was compiled by archivist and planetary scientist Dave Williams at Goddard. And tracking tree height and biomass of these control specimens, as well as the moon trees over time, helps NASA Earth scientists study climate change and the role that trees play in regulating the climate. So on November 11th, 2022, Artemis 1 launched carrying roughly 1,200 tree seeds aboard the Orion spacecraft. 4 of the 5 original species were selected for the Artemis mission. Earlier that year, it was announced that the Artemis Moon Tree Project would replace coast redwoods with its close relative, the giant sequoia, because of its greater natural range and, quote, widespread use in parks and arboreta. So before launch, the seeds were X-rayed to ensure the viability and to provide a comparison to see if exposure to microgravity and radiation had altered the internal composition of the seeds. The seeds were also packaged in specially designed seed raviolis, as they're called. These are pouches composed of 6 millimeter plastic that is thick enough to support the seeds and keep out moisture, but also thin enough to cut down on the bulk and easily store within the Orion spacecraft, and also cut down on the seed explosion that happened in Apollo 14 to kind of keep these seeds nicely secured. So this special payload of seeds traveled nearly 270,000 miles from Earth before splashing down the Pacific Ocean, December 11th, 2022. Thus, the Artemis moon tree seeds have traveled farther from Earth than any other living thing, surpassing the roughly 250,000-mile distance reached by the Apollo 13 astronauts. Upon returning to Earth, the seeds were temporarily stored at Kennedy Space Flight Center in Florida before being sent to the Forest Service facility in Bend, Oregon for study and germination. In Oregon, the seeds were x-rayed a second time and germinated along with control seedlings to determine if their journey had affected their potential growth. Although Apollo-era testing determined that the trip around the moon didn't affect the seed viability, the Artemis moon tree seeds traveled considerably further and spent about 4 weeks in space. From there, the seedlings will be sent to regional distribution centers before being delivered to their permanent homes at various educational and government institutions across the country. So in August of 2022, NASA announced that museums, universities, and federal agencies, including NASA field centers, could apply to take ownership of Artemis moon trees through NASA's Artifact module. The organizations would be evaluated on, quote, their suitability to care for the various tree species and their ability to maximize educational opportunities around the life and growth of the tree in their communities. These institutions were going to be notified across 4 planting phases in the fall and spring of 2024 and 2025. So many of the initial institutions selected for the first round are affiliated with the astronauts for the upcoming crewed lunar flyby in Artemis II. For example, 2 of the sites chosen in North Carolina, Christina Cook's home state, or the governor's mansion, and one tree for her high school. And you can see the entire crew here is present and posed for a photograph at the planting of an Artemis moon tree at the United States Capitol building. So along with announcing these seedling recipients, NASA's education and outreach offices also rolled out a number of learning modules and activities meant to engage the public, especially children, with these newly planted seeds. Among these initiatives are moon tree trading cards. It's a 33-card deck that includes profiles and photographs of notable NASA engineers and foresters, as well as some lesson plans. And for younger children, the Forest Service also put out a coloring sheet with information about the NASA moon trees and a series of educational videos meant to engage school children with the project and provide updates on the seeds' germination and their study. So the Artemis mission shares a number of key differences with the Apollo-era mission. The most notable difference being, as Cecilia mentioned, the involvement of NASA from the very inception of the project in the Artemis generation. The original seed for the Apollo-era program came from a single man fusing 2 seemingly unrelated careers into a single project, and then NASA recognizing the public relations potential in an era that desperately needed such inspirations in this space slump of the 1970s. In contrast, the Artemis reboot was conceived from its very inception as an educational and public relations initiative with programming, press releases, and publications along every step of the process. Another key difference is the selection process for the moon tree recipients. Very little is known about how the Apollo era, that selection process happened, if there even was one. All we know is that on paper, each state was supposed to be allocated between 2 and 4 trees, although some states and even individual sites received more. It seems to be that choosing planting sites leaned more in significance in the field of forestry rather than the NASA-related sites. For example, in the case of Tennessee, the state forester at the time, Max Young, received the seeds and he made the choices where they were distributed, and he chose places that held significance to him, like the University of Tennessee Forestry Experimentation Station and his alma mater and mine, Sewanee, the University of the South. So although the first round of Artemis moon tree recipient sites seemed to align with personal connections for those involved with the project, the call for applications went out to a much wider selection of education and government institutions, and there are also over double the number of seedlings available for distribution. And as for similarities, it's something that Cecilia mentioned as well. The most important one is this kind of same enduring fascination that moon trees inspire. They differ from other sites of public memory as they are both artifact and monument, and they stand as, quote, living leafy testaments to humanity's first voyages to the moon. And I'd like to share just a brief poem written by a Sewanee student named Ann Barton Robinson Carter that she wrote in the early 1980s about the moon tree on campus. It really happened, you know, hundreds of seedlings to the moon and back in 1971. Was it just to say they did, a boondoggle, the ultimate road trip, a journey for the sake of the ride, or were they altered, inexplicably changed in some fundamental way? I've seen one of those moon trees. You'd never know it had been unless someone told you. A sycamore, it stands tall like the ones around it, no discernible difference. Its branches stretch no higher than the others nearby. Its leaves move from green to yellow before discarding another year. Its roots are securely earthbound. Perhaps, though, when night falls and we sleep, something internal and unseen awakens. Maybe there's a hidden monitoring of the waxing and waning, a deep knowing, an undetected communing, an unprecedented exhilaration of recognition on nights when the full silver orb shines, and a yearning for a place visited and never forgotten. Or perhaps the shift is only perceptible in the darkest moments, when the deep black velvet curtains close and no lighter comfort can be detected. There may be a lonesome keening, an inconsolable grief, a loss lost on those who slumber. If not, it would be nothing to be a moon tree. So this poem speaks to one of the most kind of fascinating aspects of the Moon Tree project, that although the journey itself likely doesn't alter the seed in any physically discernible way, NASA and the US Forest Service has still taken on the tremendous effort and expense to send these seeds on what is to date the farthest voyage that any living thing has ever undertaken. So the reason for this is the undeniable power of the moon trees to inspire human creativity, whether it be in poetry, literature, art, scientific exploration, or STEM fields. So such programs with the mission to inspire, like moon trees, are crucial in securing long-term financial and emotional investment in space exploration. So, and with this conference's focus on preservation, we can see both the Apollo and Artemis era moon trees not only as historic sites in need of preservation assistance, but also as kind of tools of preservation themselves. You know, they preserve this intangible resource of inspiration. That's it. Mm-hmm.